Hello viewers, welcome to my channel KK Concepts of Electrical Engineering. Introduction to electromagnetic fields. The name itself tells us it is the combination of electric and magnetic fields. Let us see what is a field. A field is a spatial distribution of a quantity, can be either solar or vector in nature. Spatial is nothing but space or around it. If this quantity of distribution is an electric charge, then that is known as electric field. If this quantity is a magnetic charge, then that is known as magnetic field. You can see in this picture that electric field is around two electric atoms. The magnetic field, we all know that it's going to originate from North Pole and ends at South Pole. What is electromagnetics? It is the study of the effect of electromagnetic charges at rest and charges in motion. We have three different cases in this. If the charges are at rest, then that is known as electrostatics. If that quantity of charges is in steady motion, then that is magnetostatics. And if that charges are varying in motion, then they are known as electromagnetics. Let us see a brief history of electromagnetics. So we can observe in 200 BC, campus is invented. The static electricity is invented in 400 BC by the Greeks, and Ampere law in 1823, Faraday's law 1838, KCL, KVL 1845, Maxwell's equation 1864 and 65. So electrical machinery was invented in 1832 even through electromagnetic theory. Modern emerging areas impacted by electromagnetics are many. We can see signal processing, computers, lasers, nanotechnology, remote sensing, biomedicals, wireless communications, everything. All are impacted by electromagnetics. As we know that field can be either a scalar or vector in nature. We must learn what is a scalar and what is a vector. Scalar is the quantity having only magnitude. Example. Vector is the quantity having both magnitude and the direction. Let us see what is unit vector. A unit vector is a vector with a magnitude of 1 unit, and the formula and how it looks like you can see here. Now position vector. We can see that the position of vector p, that is denoted by x, y, z, then the position vector can be written as r bar is equal to xi bar yj bar plus zk bar, since the x-axis is denoted by ith vector, y-axis jth vector, and z-axis kth vector. Now distance vector. To find the distance between p and q, p is having the coordinates of x1, y1, and z1. Q is having the coordinates of x2, y2, z2. Then P position vector will be P bar equal to x1 a x bar plus y1 a y bar plus z1 a z bar. Then Qth position vector, we can see x2 a x bar plus y2 a y bar plus z2 a z bar. Distance vector of PQ. Then PQ is equal to, we have this formula. By using this formula, we can find out the vector of PQ, and formula is useful to find out the magnitude of this vector, and this formula is useful to find out the unit vector of this distance vector, product of vectors, or else vectors product. This is again two types: dot product and cross product. Dot product is scalar one, equal to the product of the magnitudes of the both two vectors multiplied by cos of the angle between the two vectors. Since it gives a scalar value, this is known as a scalar product, cross product. This is given by the magnitudes of the two vectors multiplied by sine of angle between the two vectors and unit vector which is perpendicular to the two vectors. Since the value is a vector, this is also known as a vector product, coordinate systems. In order to describe the spatial variations of electromagnetic quantities, we require appropriate coordinate systems. We have three types of coordinate systems, that is Cartesian, cylindrical, as well as spherical. Cartesian system is three-dimensional system which is having x, y, and z coordinates. Each value of the each coordinate is going to vary between negative infinity to positive infinity. To find the differential lengths of x direction, that is given by the dx, the differential length of the y direction, y coordinate ay, differential length of z coordinate at dz, then differential displacement is given by the value of dl. Then the formula for dl you can see here. Then differential surface areas. If you are finding the differential surface area of x plane, then it is dy, dz, ax, and so on. And the differential volume, the value dv equal to dx, dy, dz. So cylindrical coordinate system represented by rho, phi, and z. Rho is going to vary between 0 and infinity, phi is going to phi, and z is going to vary between minus infinity to positive infinity. Same thing, here we're going to find out the differential displacement, differential surface areas, and the volume of differentials. You can observe the differential surface area of ds of x, or rho we can say here since it is a cylindrical coordinates, is given by rho dq multiplied by dz and arrow. Arrow is the vector which is normal to this plane. Similarly, ds is given by d rho and dz and vector a phi. Similarly, ds z. Then the volume differential is given by the formula spherical coordinate represented by r, theta, and phi, where r is going to vary between 0 and infinity, theta is going to vary between phi, and theta is going to vary between 0 and 2. Similarly, we need to find out the differential surface areas and volume differentials. We have relations between Cartesian and cylindrical. If we know the cylindrical coordinates, this is the formulas to find out the Cartesian coordinates. And if we know the Cartesian coordinates, these are the formulas to find out cylindrical coordinates. Here, the relation between Cartesian and spherical system. If we know the spherical system coordinates, we can find out the Cartesian coordinate formulas. Similarly, if we know the Cartesian coordinates, we can find out the spherical system coordinates by using these formulas. These are few formulas for Cartesian to cylindrical transformation. These are the formulas to transmit Cartesian system to spherical system. And we have types of operators, del operator as well as the curl operator. Finally, we can conclude that electromagnetic field is a spatial distribution of electromagnetic quantities. Electromagnetic quantity can be either a scalar or a vector in nature. Finally, electromagnetics, the study of the effect of electromagnetic charges at rest and in motion. If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.